Hello, hello, hello. Welcome. This is actually take two of the video. There were some slight issues that we had to fix. Today's overview, we're actually going to start Unit 3 for code.org for my students. My principal of engineering students are doing a movement section where they talk about programming like what you would do in like an intro robotics course. So I found that Unit 3 lends itself to that, and I wanted to go through this unit with them. Unit, we're on lesson 4. The first 3 are more hand-holdy in-person assignments, and since we can't do those, we're just going to skip to these and give them a brief intro to coding. And then after this, I'm going to do 5.1 and 5.2 for my digital media kids, which is going to be similar to previous videos I've done with coding and pixelation and art. Their ultimate goal is to eventually make phone mobile apps for fun. And CodeHS has this as well, but I kind of like introing it with code.org, and I kind of switch between them simultaneously. So, we will see how this goes. Students use the App Lab environment, first time becoming acquainted with the turtle. G program is the most efficient way to draw an image in 3x3 grid. So I've done this too as well with CodeHS, so it'd be a little bit simpler, or it's just a different way of formatting the same things. As we catch my cursor going all the way across the screen. There we go, I get to scroll. So pair programming, method in which two people pair up. So I would pair them up together and let them talk each other through it. But since they can't, we're here going to do it ourselves. Turtle programming is a classic method where you're given a turtle and you're given these commands that allow you to move the turtle a certain way. We're going to watch the video really quickly if it's not too long. Let me see. I forgot how long the video is. Only 3 minutes? Cool. You know what? I think usually I would watch the video, but they know to watch the video at this point. I think I'm going to save us some time, ultimately, and we're going to get into it. Pause your video right here and go watch the video if you have not. All right, are you back with me? Good. That was for video purposes. All right, so now we're going to actually go through these commands, and we're going to start there. So, given there are only 4 turtle commands, draw a 1x1 square in the front and left of the turtle, efficiently as possible. Program should stop when turtle is at the original position. So, they kind of give you a hint here. And note that they said start at the original position. So, for this first part, I want to make sure my cursor is... Yeah, y'all can see my cursor is... So I'm going to go ahead and understand where I am. I'm pointed up. I'll use up, left, down, and right instead of north, south, east, and west and all that. I want them to move forward. And we're going to do a turn. Say if I'm looking at the diagram they gave us, they're doing a whole bunch of left turns. So move forward, turn left, move forward, turn left. Now, I essentially have this down, but I'm going to stop in the middle to make sure it's doing what I want it to do. Also, I'm going to kick this speed up a little bit. It's just from turtle to kind of rabbity. So we're going to run it. Bang, bang. You can be a little faster. But maybe a little too fast. Slow it down just a little bit. I want them to see the movement. All right, so... here's the thing. We're going to do move forward, turn left again, because we got to finish the square off. Move forward, turn left. So this should get us, if we run this, that gets us back to our original position. And then this is how we know if we're good. It should make a sound. Let me make sure I have the ding up correctly. Ding, properties. I didn't have it on. Good. I'm going to fix it now. So now when I hit finish, it should ding. Or maybe my TV is low. I should have heard it ding. We're going to hit continue. And we're just going to go through these. I really enjoy them. They're very interesting. Let me get my volume right. All right. This time draw a 1x1 square to the front and right of the turtle as efficiently as possible. No command to turn right. So how do we make a left go right? So we have to use our skills for this. We're gonna move forward. All right, moves forward, run. Instead of turning left, I wanted to turn left a couple times because 2 right will make you backwards, but we want to go all the way back to where we were. I think we want to do, actually no, let me try it with 2 lefts. All right, click run. Doom. Okay, so 2 lefts, exactly what I thought. 2 lefts would send you back the way you came. So you need 3 lefts this time, because 3 lefts will make a right, essentially. This lesson is brought to you by Daft Punk in my ear. Sorry you can't hear it because of YouTube's copyright claims. I would love to have some Daft Punk going on in the background. I might just do it anyway at some point. So we want to do this again once we had the orientation. Oh, see, y'all heard the O? I rushed it. I was trying to run. Boom. Turn it around. Oh, it changes the speed. Okay. Kick you up. Alright, so as you can see, I'm back at the position I wanted to be. And now I can make those right turns. So we're going to keep going from here. Throw in 3 more lefts. Now, again, the common theme with my videos is that if I can do this and make my life easier, I'm going to. So I took it out of block text, which I actually prefer block text, but for the sake of being able to repeat these commands simpler, I'm going to Control V and Control V. And if I did this right, I can go back to the block text and save myself some time. So reset and run. This should get me exactly where I want to be. Boom. That speed can be up a little bit, just a little bit more. And there. We should be able to finish from there. Congratulations, we completed the puzzle. Wait, is it giving me the ding? Why isn't it making the ding? I don't understand. It has this like, ba-bum, you did well sound. It's not doing it. So, let's draw a 3x3 grid to the front and right of the turtle as efficiently as possible. Okay. So we have here the amount of number of right turns. I'm gonna see if I can carry over that code. To the front and to the right. So I need to definitely need to speed this up. All right, one more. All right, we're on show text still. Okay. Check. Okay. So cool. If we are going to do this the way that I envision this in my head, we're going to reset and run. Bang, bang. I thought I put the extra one there. I did not. Alright. Alright. Alright, so I'm gonna, sorry, I had a mental moment there. Alright, we're back at the original square. However, so this gives me one square, but I need to do this multiple times. So if I know that this is my square coding, I'm gonna take all of this and I'm gonna copy it because that gives me one square. So now all I need to do is set positions differently and then do the code again. So if I do, nope. All right, bring my blocks back in. I'm gonna put a move forward in and see where that takes me. Because I want to change my positioning to that. So now look at where the positioning is. We have this little part right here, so we can technically start the next show text. We can technically start the next set of squares. I'm gonna Control V in my whole block again and run it. Okay, so that's gonna give me the second one. Now, they did say efficiently as possible. Would I have... There's probably a better pattern for this too. I mean, I'm individually doing 9 different commands, but I'm changing positions in between with what I thought. I'm trying to think. I think I'm gonna go with what we have. And back into its original direction. So I'm gonna play around with the orientation some to make this work. So right now I need to move forward. Can I drag in a bottom one? I can just drag it in. That makes my life easier. I don't have to keep switching back to block. All right, and then we throw in another set of code. And we dum 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 dum. All right, so this time I want to, at the bottom, I'm going to, we're going to move forward, turn left, and move forward. Move forward, turn left, and move forward. That should, let's set up our positioning before we do our next square. Oh, that was one left, huh? So I need another couple turn lefts in there, right? Reset and run. I think you get it from this point. I'm gonna move on from this particular example because we can, we can do this all day, and it will just take up most of our time. However, I don't want to do that to you. I'm gonna at least give you this outer part. Cool. And that's built to be that way. So we're going to go ahead. What is the meaning of efficiency? So you think about the example I just did. the efficiency and the fact that I actually use my Control V command to paste the same lines of code again for the square itself, and I just had to change orientation between them. How can I make the same amount of code but in fewer lines? So there are competitions out there where you do have a set of code, and then you use loop structures, what if structures, for structures, to simplify it to where you don't have to write as much, and it still gets the same amount of job done. Today solve a series of problems with limited commands. Yeah, give us a turn right command. How briefly describe how the code for drawing a rectangle would be different from drawing a square. It would have more move forwards before the 3 turns. So it would be move forward, move forward, move forward, and then do the 3 turns to go right. 4 times moving the turtle forward and turning right or left to change your rectangle. So that's that first lesson. I think I'm going to leave it there for them. Yeah, and we're going to go ahead to the other unit. So the other unit, if I just tap over, is event-driven programming. This is for my digital media kids. Lesson overview. So here, students are introduced to the design mode in App Lab. Students are allowed to easily design the user interface or UI of their apps. It's a callback function, event function specified in event listener, event, an action that causes something to happen, event-driven program designed to run blocks, event handler, event listener, and UI elements and things like that. So we're going to learn on event, set position, set size, and then there's a video that I'm going to let the kids go ahead and watch on their own, which I love these code.org videos. I think they're bright, colorful, and they're meant to be that way. So I would tell my kids to read this section, or normally we would read it out loud. But I'm going to go straight to the design. Because again, to a design mode versus so design mode versus the actual create code mode. So we're gonna go ahead and start this way. This is your workspace. Switch to design mode and drag a button on there. Change the text to say click me, make the color of the button red. So I love when we get to this point in digital media because I honestly put one of the kids in the front of the room and I let them work the main computer while we talk them through it. So I'm going to switch to design mode. I'm going to drag a button on there. I'm going to be a rebel and not make it red. I'm just kidding. I am going to make it red. It is now a red button. And I don't think they actually... Sorry, I went a little too fast there. So we dragged the red button on there. So now it's recognized as a button. It has button 1 as the ID, so that's how we would call it. But I tell my kids all the time, you're not going to know button 1, 2, 3, 4 from, this, that, or your left foot. So we're going to call this the click me button. So click me BTN. Click me button, so that when you go to code, it's the click me button. And we're going to change the text to say click me. Cool. And then we can run it. Alright, and finish. Alright, so we have the click me button down. Now event-driven programming will tell us when we set up those on events, they should click and do those actions. I would make them read this whole thing, and we're going to go through it. I'll keep that in mind. I'm kind of looking to the left, but my work screen is over here, and it's much bigger. I like having my work on the bigger screen to work through. It says add an on event block and set the ID for your button and then make it move forward when you click that button. All right, so on event. Whoa, give my blocks back. This is why I prefer block programming, because you can actually see the brackets that it contains. So on when I click here, I click the click me button. On the click, it'll actually do whatever function we put inside. So then we're going to say move forward, command. And really, I don't think it actually tells us what the pixels are. I think they have it set to certain numbers. Yeah, let's do 25. So if I run it and then I click me, it'll keep moving forward as I want, as many times as I click. So I want to reset, and for the sake of being nitpicky, I'm gonna drag my button down and out of the way. Click, 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 click. All right, cool. So that's that first part. Yeah, we have plenty of time. I might as well go through the whole lesson, right, guys? So it says in design mode, drag another button onto the screen, and we need a touch turn left button. Oh, and we need to change this one to go forward. Okay, so we're gonna be that person. I'm gonna drag you over here. You are no longer the click me button. You are forward BTN. Forward BTN for forward button. And you're now gonna say move forward. I wish I actually, no, let me not do that. I was gonna be weird. I was gonna also put the left button as izquierda. I think that's just right and izquierda is left. And I say this, but I can't remember left and right in Japanese right now, so I'm kind of failing. I need to go look that up later. And now I'm curious. Brief change. So that's how you spell. How do you say it? Oh, Hidari. I knew that. Hidari. So Hidari versus Migi. I wonder something real quick. Oh no. I want to check something. I'm being weird. My hiragana is there. Google doesn't recognize it. Or sorry, code.org doesn't recognize it. So I have a text tool that lets me type in Japanese in certain apps, or just on my computer in general. And I was trying to be cool. Oh, wait. Maybe? Oh. It does it. Okay, so that's Migi, which is right in Japanese. Hidari. Who gives me these things? Hidari. That means left. Hidari iku. So go left? I don't know. Anyway, I'm doing too much right now. Hidari iku? Way too much. Alright, I'm gonna stop. Get out of. Go back to English. We're gonna do. This is my forward button. Wait, it should say go forward. Alright, so I'm gonna duplicate you and make my life easier. make sure they're in line. All right, I hit the duplicate button. We're gonna call this the left button. So left BTN. Technically, we would do this. Good old camel casing for when we type. So camel casing is defined as coding in which you help you have your identifiers, where you put one of your capital letters in the middle, like a hump in the middle, like a camel. So left BTN would look like that. So when I click this one, really, I'm gonna change this to F, and then change this to big B. Forward button. Camel casing. All right, so change this one to say go left. Let's put some emphatics in there. Emphatics. Go forward. So go forward, go left. Cool. Emphatics are there. We're gonna go to code mode and run it. So on event, now it knows to turn left when we tell it to turn left. Now, notice here, these parentheses are set for your parameters. How far forward do you want to go each time? How far left do you want to go each time? So 25 pixels forward, and then the left and right commands are by degrees. So if I wanted to do a full 90-degree turn left, I'm going to make that take full 90-degree turn left. So now when I run this, oh, hey. All right, so warning, I'm glad I'm showing this off. Your debug console is going to let you know when things are not as they should be. Remember, we changed the name of these buttons, so I need to actually switch them back. So this one should be the forward button, and this one should be the left button. Oh, except I didn't spell that right. Mr. Clark, go back and fix that. Why? Because left BTN. None of y'all were gonna tell me. I'm just kidding. No one's here. Go watch the video because that's what this is for. So we're gonna go to code mode, and then we're gonna go left button. Cool. So now when I run it, it should have no issues. Go forward, go left. Go forward, go left. Go forward, go left. All right. Now that you know the pattern, add a second button. Screen turns the... Oh, okay. So go forward, go left, go left, go left, go left, go forward, go left, go left, go left, go forward, go left, go left, go left. Now we're featuring the puppies. All right, cool. So we get it from there. We're finished. Continue. Add an event to code, blah, blah, blah. Programming patterns. What's our next assignment? Event-driven patterns. I think it's better to just kind of look at them. Choosing good IDs. Again, this is what I was talking about, using your camel case instead of saying button 1 and button 2. You actually give them the names is what to do. I kind of went ahead of the lesson because I've done it so many times. Camel case, there's defined here, underscores, help you keep things together. A camel case name might look like this. Some people like to use underscores to separate words. Others use dashes, and that's all fine and dandy. Wait, why does that one not have? Continue. I wanted to make sure that it has a green dot. Not that it actually matters. All right, you try it. Give your button descriptive and meaningful IDs. I do have them already. All right, so here we're going to learn about the different ways that we can do this. We have clack, clack, how do I sound? Click. And then we have mouse move and mouse down, and then mouse up and mouse over. So depending on how you want your apps to interact, you might change those around. So we have two perfectly used buttons, so let's change how they interact. Let's look at mouse move and see how that behaves. And let's look at mouse over and see how they behave. So I'll do mouse up and mouse down differently. So mouse move and mouse over, where are you? All right, cool. So now they should behave differently. Now the forward button has mouse move. All right, so you see what kind of happened there? It kind of took off. So mouse move simply says the moment it touches that button, it's gonna, the moment the mouse moves on this button, it's gonna do the command. Now let's look at the go left. If I mouse over is gonna do it for each individual time you actually get the mouse. So as you can see, I'm going up and down, ba ba ba. So it depends on how stagnant you want it to be. I did too much. Alright, so you see how their behaviors are different. One scenario might be better over the other. So now we're going to reset, and I'm going to do the mouse down and mouse up commands. So forward, I'm going to give you mouse down, and left button, I'm going to give you mouse up. We're going to run. And so pay attention here because you'll have to take my word for it. The forward button has the mouse down command. If I'm clicking on my mouse, the moment I hold it down is when it starts to move. Now here's a little different. I can click and hold go left down, but since it's on the mouse up command, it doesn't do the thing I want it to do until I release that mouse. So here, it does immediately. Here, not until I release. Immediate, not until I release. So that's the difference between your mouse up and mouse down commands. Cool. And we keep it moving. Don't worry, more types of practice. Talk about debugging, common errors. All right, checking IDs. On event parameter refers to a D button 1 that doesn't exist. So what is the name of button 1? The actual name of button 1 is forward BTN. So we would go to code and change it to where they agree. That's all that is. Continue. We're kind of speeding up a little bit for time's sake. Debugging event-driven programming. So let's run it and see what they give us. Left button, which doesn't exist. So why does the left button not exist? We're gonna go to design mode. Look at the button. It's left capital BTN. So if I go back to the code, change this to left with a capital BTN. That one's good. Run. All right, that looks good to me. Everything works as it should. So this just gives you practice in debugging. Sorry, I'm kind of hitting my groove and going a little faster. Excuse me. Observe and reflect. Predict what we think would happen. So, ideally, not ideally, you have button 1 and button 1, and they're both on the click, and it's giving it 2 different commands. So which one is it going to obey? Is it going to do move forward? Is it going to do turn left? Or is it going to try to run both at the same time? So, let's see. So what do we notice? They're actually running both commands as it happens. So really we could do this 2 different ways. I could take turn left and bring it inside, and then they will work on the same click, or have it separately. Again, we talk about efficiency's sake and why this separate function that does the same thing would be separately on a different line. Yes. Feel free at any point, if you're watching this video later, to ask me questions in the comments, and maybe I can go back and answer some. So logical errors. It runs as it's supposed to. So my go forward button is turning left, and my turn left button is going forward. So how do we fix that? Easy. I just switch the buttons around. And since it's on the drop down, it's much easier to deal with. Run, and problem fixed. Logical errors. Now, let me talk about this for a second because this is kind of just like a nitpicky thing for me. I have some kids, and I'm just going to verify and just say this, that wanted to, oh, let me take this out and put the blue back in and take that out and put the other blue back in. When in all actuality, if the drop downs are right there, just switch the drop downs around. It's not going to hurt anything. So yeah, think about how you logically can fix it in the most time efficient manner. Continue. Set position and distances. So they tell us here, and this is important to know, our X distances are 320 pixels and our Y distance is 450 pixels. Just for future reference as we do this. So our set position function says choose the button that you gave the ID to, and then you give it the positions of X and Y, and then give the width and the height of X and Y. Width and height of whatever the ID is. So let's look at what we got. It says set position to move the button to the middle of the screen when clicked. Alright. Set position to move it to the middle of the screen. Middle of the screen, screen in a little. Hover over the screen to find a good standing point. Show you other hints. So if I hover, it gives me X and Y coordinates to play with, but does it? I'll talk about that in a second. So let me get the code down. So I'm gonna move the button. So drag in the on event. We're gonna say when I click the move button, set my position of said move button. And now 100 and 100 is the current size of the button. So it changes the size. Alright, so I need to know the original size of this button, because I want to preserve that size if I can, or not. Alright, reference. 144 versus 10? Wait, so then that would mean that's 130? Y values would be 33 versus... Where's my corner? Grab my corner. So I'm using my icon to help me figure out the number. It doesn't have to be exact, but you know, I want to take a minute to be exact. 32. All right, so we're gonna try this then. I'm going to go back to the code. Still with me here? All right, so we're gonna change these around. I'm gonna leave the width how I like it. Let's stick with 100 for now. I know the height doesn't need to be that big. I'm gonna go with 25. And I'm gonna run it. And then I'm going to... Oh, okay. So it looks like it didn't change that. Let me start talking about the center, because I do want it to move, period. And right now it's moving to where it's going to line itself up on that corner. So let me say I want you to move to 50 and 50, because this will give me an idea of where positioning is. If it actually positions to the center, or if it positions to a certain corner. And if I run, 50-50 is here. Show me my what was that? What was 50-50? What do I do? All right, 50, 50. So yeah, it looks to me. It looks like it it guides along that right corner. Because if I run it again, yeah, it definitely. I feel like it definitely guides along that right corner. So positioning for your button guides along there. With that being said and that in mind, we can go back and get the specific numbers, but we don't have to be that specific. So really what happens here is we said that originally the X value had a value of 320. And we said the Y value had a value of 450 up and down. So, I mean, common sense would say to cut both of these numbers in half. All right, remember the first two numbers are positionals and the last two are width and height. So X was 320, so I'm gonna make that half at 160. And Y was 450, I'm gonna make that half. 450 divided by 2 is 225. That's 220. So this will give us a good start of where we wanna be. So run, and when I click it, all right, so that centers us more so to the center, but we also have to adjust for the fact of the width of the button and everything else. So if this is true, and this is kind of easier to figure out, if the height of the button is 25, which it was, and I want to change that height to account for that, I'm going to take away half of the 25. So essentially, I'm going to take away 13 from here. 212. 212. So that'll get me more in the center height-wise because I'm taking away the fact that the button itself has to move that as well. Let's see. All right, cool. That's more in the middle of where I want it to be. So we're going to do the same process for this. If I do 100 and I account for half of that being the size of the button, because 100 is the width of the button and the total width of the button is 320. So if I take the 50 away from the 160, I get 110. Yay, math. 110, we're going to reset and run. So this essentially should get me smack dab center-ish. I could do a little better, but you know, we're just gonna go with that. Yeah, that's practically smack dab in center. Cool. So with my funny numbers, we're about where we need to be. And we're gonna finish. We're almost done. All right, so now they want us to actually make it so that we can move the button as we feel with a random number generator. So we want to preserve the height and width, so we're not going to change those numbers, but we are going to allow ourselves to plug in numbers for X and Y. So my favorite functions are coming in. We're going to grab math random and math random. Now, pause the video and get ready to answer my question. I'm just kidding. So we have to give it values to move from. And ideally, we would, use the full 0 to 320, 0 to 450. However, there's some issues with the button falling off screen, and we don't want that. So we kind of give ourselves a little buffer. So I'm going to say random numbers between 20 for X. Remember, 20 is in 320. So we're going to do 20 to 280. And then we're going to do from 0 to 450, we'll do 20 to 410 to 420. All right. So this way, we shouldn't have any issues with the button falling off screen as we do this. So every time we click, it's going to randomize our positions for us and still preserve the height of the button. Run. Boom. 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 Oh, haha. So I see now I came up with an issue. I'm falling off the screen in the X direction. And we don't technically want that, although technically in their example, the move button falls off the screen a little bit too, as you can see. So it would be fine, but in this case, we don't really want the whole button to fall off. So I'm going to actually reduce the number for that and make it like 50. Or let's do 50. Because I'd like to get, let me see if it falls off anywhere else. No, 250 means that would be like right there. It's about as close as it. Move it, move it. Alright, so that works. I had a mental thing. I was trying to see, did I really care about the extra 1 pixel that I was off by? The answer is yes, but you know, it's fine. So switch back to design mode. Drag a label on the screen. Alright, so design mode, we're going to switch back. Label. Text. Can't catch me. Oh, it would help if I was typing correctly. Oh, it actually. Sorry, I was doing multiple things just now. Alright, we are here. Our can't catch me labels here. I can make the text bigger. Text size, where's text size? Text color. Font size, get bigger. Can't catch me. And there we go. Can't catch me. Move it. Move it. Alright, so they don't tell you about this, but I'm going to go ahead and tell you ahead of time. We want to put that label in the background so it's not messing up the button. So when I go to design, I'm going to go here and I'm going to put it in depth and change the depth to the background so I can still click the button if it happens to fall on top of it. Like see right here, if the label was on top, I wouldn't be able to click the button. So I'm just going a little ahead. I'm going to finish. Oops, I didn't. Let me open that back up. We're doing. Oh, I did finish, huh? So then you talk about adding an image, and we can get real nerdy and design and make it custom. Because the next goal they're going to do is create their own little clicker chaser game. So the first chaser game is simply going to be them creating this. If I run it. You can use an image instead of the button, or put an image on the button and make it be whatever image you want. Like they chose a banana, to where you have to try to catch the banana. And that'll essentially do it for today's lesson. Survey questions, we don't need to do those. But let me go back here. Sorry. If you have any questions, again, this takes us through this first video. I did some movement programming. I did some event-driven programming. Hopefully my kids enjoyed this section of the lesson. Or if you'd like to check it out for yourself, if any teachers are out there, you can get a code.org account. Or just contact me. I'll see if we can set you up with something so that y'all can practice this on your own. Code.org is really good about giving their stuff out because they want everyone to code. Thank you so much for joining the stream or the video, for watching. Like, comment, subscribe, all that fun stuff. And have a great day. Goodbye.